Good morning, everyone. Thank you for joining us here today. My name is George Rodriguez. I'm the Vice President of Business Development here at Altech Electronics. I'm also joined here with Sunny Huang, our Strategic Project Manager. Thank you for joining us today for one of our first of many webinars that we'll be hosting here in the near future. As you're all aware, this COVID-19 situation has impacted all of us, and because of that, we are looking for new and exciting ways to engage our partners. Today's webinar will focus on photometric studies where lighting speaks for itself. We feel that our photometric studies are a value add to our customers, and we have found that our photometric studies are a great tool which allow us to bring a project from conception to completion. Whether it's a parking lot, car, dealership, warehouse, or manufacturing facility, we can provide you with an in-depth analysis that will help you win those projects. At this time, I would like to introduce Sunny Huang, who is the man behind the magic for us here at Altech. Sunny is our photometric studies, leads our photometric studies team, and because of his work, I cannot tell you how many times we have heard that because of his reports, our customers have been awarded the contract. Additionally, you can submit questions via the chat box function, which should be located at the right of your screen, and we will address them at the end of this presentation. So thanks again, and I will now hand this webinar over to Sunny Huang, the head of our photometric study team.
Good day, everybody. I just want to say hello, want to introduce myself, hope everyone's staying healthy out there. And now let's get started with this webinar. So, what is a photometric study? A photometric study, in technical terms, is a computer simulation of a light, how it leaves a fixture, and how it illuminates the surrounding area. In simple terms, it is a visual estimation of what the light levels will be on site based on the information provided. So let's start by discussing the functions of a photometric study. First, who will need a photometric study? End users and contractors are most likely to request for a photometric study so they can better visualize what will be needed on site and when would they need a photometric study. They will need a photometric study during the initial stages of their project, especially because Altech is doing this at no cost to them, so they can take full advantage of this resource to better plan. And how will it help them better plan? The photometric study will provide them with point-by-point foot counter readings, which is a measurement of light, and how to position the lights and what fixture and wattage to use. From there, they'll be able to see the potential costs and energy savings by switching to our LED fixtures. A photometric study can be done for a variety of applications, both exterior and interior. Exterior photometric requests that we have received include parking lots, car dealerships, sport fields, and sport complexes. And as for interior, they can range from warehouses to manufacturing facilities, grocery stores, and industrial facilities. We have yet to receive a photometric request that we are not able to fulfill. Now we will dive into the process to completing a successful photometric study. For an exterior photometric study, receiving a CAD file of the project site is the ideal requirement because a CAD file is a 2D or 3D computer design of the site. It gives us all the dimensional and structural information that we would need so we can then import it onto AGI-32. Now, AGI-32 is the software that we use. It's an industry-leading software that most manufacturers use. And if a CAD file is not available, then the customer can either provide a PDF blueprint or layout with a scale, or at least give us the site address so we can use the image of the site from Google Earth to import onto AGI-32. It would also be best to get a brief description or diagram of the existing fixture layout so we know the location and arrangement of each pole, light, and mounting height. And this is important because there could be unknown obstructions over the poles, such as trees or shadows on Google Earth, and images from Google Earth can be outdated, meaning some poles or lights have been added or removed since the photo was taken, so the most recent information is always best. And existing wattage would also be great because it gives us an idea as to the existing light levels that they have on site so that we can match or exceed the light levels. However, we also look at the recommended foot candle levels of each application we are running the photometric for. And when customers provide us lighting ordinance packages for each city, such as dark sky or light trespass regulations, we'll go through all the requirements in the package and ensure our photometric studies are in compliance. For example, certain cities may require full cutoff fixtures or all the fixtures to be a certain color temperature, such as 4,000 Kelvin, 3,000 Kelvin, or 5,000 Kelvin. It is a lot of information, but keep in mind, the more information that is provided to us, the more accurate our photometric study can be because we can take into account all of them when modeling the site. So this is an example of a PDF layout we received for a project recently completed. This was for Mira Mesa Marketplace in San Diego, California. And this was perfect because this PDF gave us all the information we would need, such as where the buildings are located, the parking places, and the location of the light poles. We can then import this image directly onto HGI32 and build the design from there. However, George will be able to go into further details and framework the obstacles that we faced from a sales perspective on this project. George?
Thanks, Sony. So for this particular project, the customer came to us looking for a solution that would enhance their customer's experience. This particular center has some high visibility tenants such as Home Depot, Ross Dress for Less, a movie theater, as well as several specialty boutique shops. What the customer was looking for was to limit the glare while maintaining a sense of safety and security for their shoppers. So Sony took this information into account, and he came up with a solution that exceeded the customer's expectations. And yes, he can do that for you too. So the fixture that was chosen was our new Hyper Series area light. I will now let Sony explain a little bit more in detail why he recommended this particular fixture.
Thank you, George. So now that we have selected the Hyper Series area light, since this is a parking lot, the real question now is, how do you know which wattage to choose? And there are two criteria we take into account. First is the existing wattage, because that will be a baseline to start with. Second is the recommended light levels for the application. In this case, a parking lot. So between 0.2 to 2 foot candle average and 0.2 minimum, because that's the recommended level for security purposes. The recommended light levels for the application is more important later on, which we will discuss further, as it would help us adjust accordingly to reach the levels that the application calls for. Also, as mentioned, it is good to know the existing arrangement of the lights because it will help us in determining the best proposed arrangement. Now, what do we mean by that? For example, because of our high lumen efficient lights, which is usually 165 lumens per watt, we could perhaps use 2 heads instead of the existing 4 heads per pole that the customer has on site, and actually provide the same or even better coverage. And we have to also select the right optics. For example, in a wider space in the parking lot, we will normally use a type 3 distribution. In a narrow space, we'll use a type 4. And for a single pole in the middle of a parking lot, it is usually a type 5 that we use. And as mentioned before, depending on the customer preference or city regulations, we will select the color temperature from there, whether it be 4,000 Kelvin or 5,000 Kelvin, although most of the time it is 5,000 Kelvin. Now that we have the preliminary information needed, we can start building the layout. So from the details provided, we build the model on HGI32 from the ground by adding the buildings, parking lot lines, and poles with the fixtures on them. From there, the computer is able to take into account all this information that we feed it and calculate point-by-point foot candle readings. From the calculations, we're able to analyze and look for areas that perhaps don't meet the minimum foot candle requirements or perhaps there's too much light trespassed on neighboring streets. And this is where the real magic happens in our photometric study, because from this initial solution, we can work on how we can further improve upon it. We have many different options to do this, such as tilting the fixtures, changing the optics, or changing the wattage to find the best solution. We also work with the customer during this process, if need be, to find the best solution for them. So in this case, we ended up with a 150 watt Hyper Series area light as the best solution at a 1-for-1 replacement. So from those calculations, the software is able to render and provide a visual model of the layout with the light. So all those modeling that we did earlier, such as adding the buildings and drawing out the parking spaces, those were crucial because it gives perspective to these 3D renderings, and it allows the end user to better understand where the poles are located and what kind of light patterns they'll be getting around the parking lot. The software can also produce a rendered heat map, which allows the customer to visualize the light levels as it pertains to the vertical surfaces and buildings on the project. And that is another advantage of LED fixtures as opposed to traditional lighting, is that we can direct LED light, meaning we can reduce light waste and glare by directing it. In this case, as George mentioned, shoppers were complaining about some glare coming out of the shops, so we directed the fixtures down to reduce the glare. So once everything is done, we can produce the finalized photometric report with average foot candle readings. As you can see, the average foot candle readings on this parking lot is approximately 4 foot candles. We're also able to provide the maximum and minimum foot candle readings and uniformity ratio. Those maximum readings are usually directly underneath the pole, and the minimum 0.2 foot candles met security recommended levels. Now there are a total of 122 lights, and as you can see on the top left here, there are 22 single poles and 25 poles with 4 heads on them. So anyways, although this is higher than the average foot candle for a parking lot, customer was extremely satisfied with it. However, they still wanted a live demonstration to support our photometric study, so we were able to send them free samples of both our 150 watt and 120 watt light to test, and they loved it. They actually decided that the 150 watt option that we proposed in the photometric study was indeed the better solution for them. And after all, they are still saving 250 watts of energy per light, since this ended up being a 1-for-1 replacement. And here are the project photos after install. As you can see, it mirrors the light levels we discussed. We were able to turn this project from conception into completion in less than a month, and the end user was extremely happy. They actually ended up using our fixtures across 2 lots. This lot alone involved over 120 lights, and the customer added motion sensors as well to further capitalize on energy savings from the sophisticated functions that our motion sensors have to offer. Next, we'll explain how to do an interior photometric study. But first, what constitutes an interior photometric study as opposed to an exterior one? To us, anything with a roof is considered interior. Even like a barn that is open air is considered interior, as long as it has a roof, because we can remove the walls on AGI 32. And you might be wondering, can we run a photometric study with interior and exterior applications in one? And the answer is, of course we can. We've done it several times for our customer, as long as we provided all the necessary information. And as mentioned before, the more information that we are provided, the more accurate our layout can be. So anyways, like an exterior photometric study, a CAD file is best because it gives us all the structural dimensions inside the room and any stationary objects that we have to take into account. And if that is not available, either a PDF blueprint of the room or even just a simple drawing is fine, as long as it has the room dimensions such as the length, width, and height, because we can then draw it out ourselves on AGI 32. And even the roof type, such as having a peak, is good to know because we can model that on the software. In an interior photometric, since it is enclosed and light has more surfaces to reflect on, providing all this information, such as objects inside, color of the surfaces, such as the walls, is crucial because it will affect the foot candle readings, and this is otherwise known as the reflectance value. For example, white surfaces reflect more light, and darker surfaces absorb more light. And we would also need to know the existing fixture layout within the room, such as the mounting height and distance between the light, especially if it is a retrofit solution, so we can match the electrical grid accordingly. And finally, the existing fixture wattage is recommended so we have a baseline to start with, but we also look at the application to determine the light levels the customer would need. For example, a warehouse is usually targeting 30-foot candles. Now this is an example photometric request that we received. It was for a basketball court, and the PDF showed us the dimensions of the gym and the fixture locations, and the customer provided us with the mounting height, which was 20 feet. But I'll pass this on to George again to give us a better perspective on this project from a sales point of view.
Thanks, Tony. So for this particular project, this interior project was for a sports court / basketball court where we were asked to provide a lighting solution as the customer was complaining about some dark sections on the floor. One of the best things that Sony does is take into account the light level recommendations for a particular application. For example, as you can imagine, there are different levels of play for a basketball program, from youth recreational leagues to high school and college level basketball, and obviously the NBA. At all the various levels, there are different requirements that will affect the fixture that will be recommended. In this case, the recommended fixture was our UFO high bay, which has been a go-to for many of our customers. I will now hand it back to Sony so he can explain how he came to the applicable solution for this project.
Thanks, George. So in this case, it was pretty straightforward because the customer requested for a 100-watt UFO waterproof high bay. However, as mentioned, we have to also take into account the application to when specifying a wattage if it's not specified. For example, if the mounting height is low, such as in a grocery store, we try not to have the wattage too high to reduce the glare for shoppers. So instead, we will recommend to the customer to use a lower wattage but have this more fixtures spread around, as opposed to having less fixtures but higher wattage. So same with this project. We have to keep in mind that it is a basketball court, because even just for a basketball court, there are many recommended light levels. And as George mentioned, different levels of play require different light level standards, such as NCAA or NBA and television broadcasts. And most of our interior photometric study involves our high bay UFO, which comes with a default lumen package of 130 lumens per watt, but we also offer 165 and 185 lumen per watt options as well. So now that we have all the information, we're able to build the basketball court by drawing out the court and the room based on the dimensions provided. So although we proposed a 1-for-1 replacement at first with 16 fixtures, the customer actually wanted more light after seeing the initial report. So we offered them more solutions and photometric reports. These solutions include increasing the lumen package but with the same number of fixtures, or keeping the fixture the same but increasing the number of fixtures. And eventually, they preferred the option with another row of light for a total of 20 fixtures. Now, once again, the software renders the image and produces this 3D image here, which again helps the customer visualize how the light distribution will look in the gym and see if the dark space that they had issues with before are now addressed. The rendered heat map produced by the software also helps the customer visualize the light being washed on the walls inside the basketball court. And finally, we're able to produce the completed photometric report. In this case, we met the foot candle levels for recreational use of approximately 30 to 50 foot candles. Our calculations showed an average of 45 foot candles by using 20 fixtures, which the customer was satisfied with because it was the best solution in terms of both light performance and cost for them. And here's a photo of the completed project. As you can see, there are 20 fixtures and the gym is much brighter and it addressed all the issues the customer had before. And now we have another happy customer. So ultimately, what are the benefits to a photometric study? First and foremost, it allows the customer to make a better informed decision on their lighting solution based on professional and technical recommendations that we provide as proven in the photometric studies, and especially for end users who are not familiar with the technical information regarding light levels. The photometric study gives them a visualization instead of just words and numbers that they otherwise will not understand. And also, as demonstrated, we will go above and beyond for every single photometric you send to us. We will collaborate with the end user, with your permission, of course, and you, to best understand their needs and how they want to light up their application. We also turn it around in 48 to 72 hours to give time for the customer to review and provide feedbacks and any changes needed. In addition, our high lumen efficient fixtures mean the results of our photometric studies are better than most in terms of light performance and energy savings. And our fixtures are also DLC premium, meaning they meet and exceed the rebate incentive dollars. So ultimately, high lumens per watt equals higher energy savings, which means dollars saved for the customer.
Sony, thanks again for that in-depth presentation today. We hope that you're all able to take advantage of the many resources that Altech has to offer here. And remember that we're not here to sell fixtures, but rather to provide solutions and create opportunities. At this time, I would like to pivot to our Q&A section of our presentation, where Sony and I will take some of your questions. Sony, please share some of the questions that may have been asked today.
Thank you so much, George. So yeah, I see several questions. We'll try to get to all of it today. I see, do we have a frosted lens option available to reduce glare? And the answer is yes. We do offer frosted lens options to reduce glare of the light chips. And let's see. Please explain the min to maximum ratio. Min to maximum is taking it's basically the uniformity ratio. It takes the maximum foot candle reading on the parking lot and the minimum, and it divides that, and that gives you the uniformity ratio as to the light distribution across the parking lot. Let's see, what other questions do we have? See, how important is bug rating when doing this photometric study? Great question. So for those of you that don't know, bug stands for backlight, uplight, and glare. And yes, we take into consideration all this so that we don't blind the customer, and so the backlight doesn't exceed any light trespass regulations. And what do we get with a photometric study? I hope I'm answering your question right, but a photometric study provides point-by-point calculation and also those 3D renderings and heat map you saw earlier. And then our sales rep will be able to provide a quote and cut sheet based on the photometric study that we provide. But I see several questions on here, and out of respect for everyone's time, I have all your email addresses. I'll be able to reach out to you personally and answer every single questions of yours. And now I pass it on to George to close it out for today.
Well, thanks again. That was a lot of information here today, Sony. Really appreciate your time and energy, and I know the effort you put into putting this together for all of us. So this now concludes our presentation. We will also be providing a recording of this presentation in the event that you would like to review it at a later time or would like to share it with some of your colleagues. Once again, thank you for joining us today, and we hope that you will utilize our resources. And remember, we are not here to just sell fixtures, but rather to provide solutions and help you to create opportunities. Until the next time, stay healthy and keep an eye out for our upcoming webinars. Thank you.
Thank you so much, everybody.